Hello guys, welcome back to my channel. Memo African Motives are still working on engineering science and form. So actually in this platform we shall be focusing on kinematics, which is the part that we are going to focus on vectors which are not rectangular. So we want to see how do we actually answer typical questions on vectors which are not rectangular on kinematics. So if you're new guys, you can consider subscribing so that you become part of the family Memo African Motives, as we shall be working on engineering science and form. So quickly rushing through this part, I have a question which is, I just wrote it down here. I hope it is going to be clear there. All right. The question reads that an aircraft which can fly at 300 kilometers per hour in calm air has to fly to an airport which is 150 kilometers directly north. All right, so take note, this is going directly to the north here. All right, then a wind from northeastern side is blown at 60 kilometers per hour during the flight. Calculate. Okay, so these are the questions that we are being asked to calculate. The first one, the direction in which the aircraft should be aimed so that it will fly straight to the airport. The resultant velocity of the aircraft and the time taken by the aircraft. All right, that is the information that we are given there. All right, so let's see guys how we answer such typical questions. So I'm just going to have a sketch of what is happening here. Okay, this is actually what is happening. The aircraft was moving to the north like this. So let's just start with something which is to the north. That is the aircraft here, right? Because it's going to the north and is 300 kilometers per hour. That is the speed of the aircraft. All right, so this is traveling at 300 kilometers per hour like this. All right, this is our aircraft, guys. All right. Then what happened is that at a certain stage, this experienced a wind. Okay, we'll talk about this later on. It experienced a wind which was from the northeast. Okay, we understand this is the concept, guys. That is north and this is east. Okay, so if it is from the northeast, which means this wind is going this way. Okay, which is actually we'll be having 45 degrees in between, 45 degrees in between. That is the wind which was being blown like this. All right, so this wind is blown to the aircraft, so definitely this is going to have a shift. It's going to shift from the direction where it was. This was actually flying direct to the north, but due to the wind it's going to have a shift. So we shall see here this aircraft shifting depending with where this is going to be, because this one, as we can see, this wind is blowing from the northeast. Is that so? That is what we're given here, northeastern. So we shall have it now extended like this. Remember guys that the from your first diagrams on your N3 that we should point from the point here of intersection out of the first, not direct. This one is pointing direct. So if it continues, it's going to be in the third quadrant, and this is going to be shifted in the opposite quadrant, which is in the what? In the second quadrant. So the final diagram now is going to look like this. This is going to be, sorry for this guys, I'm explaining too much here. I want you to understand actually what is happening here. So this is going to be your final diagram. It is no longer in the horizon, in this vertical line, because of the wind. Originally it was here, so there is nothing that is going to be in the verticals. That is why I'm putting these dotted lines. And also there is nothing that we are going to have in the horizontal line. This one, there's nothing that we shall have. All right, but we said the wind, this one is from northeast, so it's going to be taken in the third quadrant, because the forces, the arrow here is actually pointing here, so it must be taken out away from the point here. It must be from, not to point like this, it must be from. And also northeast is divided into two equal parts. You are dividing 90 degrees, that's 45 45. Okay, so this is going to be now like this. It is shifted from where it was, so let me just put it this way. It was like this, guys. Okay, so it was like this before. So let me put dotted lines where it is coming from. So this is where it was coming from the northeast. So it was pointing this way. Now it is going to be taken away from the point like this. Every force should be away like this, just like from your force diagrams. Okay, but this is 45 is going to remain because it was 45 45, so it's going to be 45 45 again. All right, then we say this is going to shift, the aircraft is going to shift this way, it's going to shift this way. Okay, so if it is to shift that way, that means we shall see our aircraft, because originally it was at this point, it was traveling this direction, direct to the north. So now it will just shift a little bit because of the wind, so that it can aim to the aircraft. Let's just say this is the shift here. Okay, guys, just forgive me here. Okay, so this is the shift. It was originally here, so it is no longer there because of the experience of the wind. It just shifted a little bit. So this is now our aircraft. So since it has shifted, it is going to be redirected by this angle here. This is going to be the angle that is going to redirect, because we do not know this angle, but this is the angle that is going to redirect the aircraft that we are given. So as we can see, we are in the east line and in the north line. So the angle is going to be east. That is, the direction is going to be east going this way to the north. So it's going to be theta degrees to the north. Okay, or you can take from the north going to the east, which is, we are going to talk about this angle here, this angle here. Let's just call it alpha, or you can write it as north alpha degrees to the east, because you're coming from the north going to the east. So it can be north alpha degrees to the east. So take note, these angles are different. That is why I'm calling another one alpha, another one theta, but there's a relationship between these two. That is, alpha is equal to 90 degrees minus theta degrees. All right, that is, if I calculate this theta, I can calculate this alpha by simply subtracting from 90, because this is 90 degrees in this quadrant. Okay, so that is our diagram, guys. Let's just put our speed. This is the aircraft. Remember, it was traveling at 300 kilometers per hour, and this is the wind, which was traveling at 60 kilometers per hour. Remember that. All right, so that is what our diagram is going to look like. Now let's answer the question. All right, the question is the direction. We are calculating here the direction in which the aircraft should be aimed, and I say this is the direction that is going to be aimed. Okay, so that it can fly straight to the airport, because it was disturbed there. So what is going to be the direction now? This one. All right, because of the wind. All right, so we are going to calculate this angle theta. So how can we calculate angle theta? We can take advantage, guys, of the vertical or the horizontal components here. Okay, so I'm just going to use H components. Okay, using H components. All right, let's use the H components, guys, and see what you're going to have. We know that the horizontal, this is in the horizontal, and they are equal to the ones which are on the left. So you're simply saying hx left or right, let's just say right here, is equal to hx to the left, that is the horizontal to the right, is equal to the horizontal to the left. So this is to the right side, so it's going to be horizontal is 300 cos, because there's an angle of theta here. So remember, horizontal always, it carries cos theta. I talked about this before. So it's going to be 300 cos theta. So you've got 300 cos theta is equal to hx to the left. So this is the one that is to the left of 60, but there's an angle of 45 degrees between Remember, we take the angle between the wind here and the horizontal line, this one. So this is the angle that you're going to take, just like this one, horizontal and versus the, okay, so we are going to take 45 degrees. So it's 60 cos 45 degrees, like this. All right, the moment you have this, that means you've formulated an equation that you can use to calculate angle theta. So guys, these are the stages that you're supposed to take even if you're answering any type in exam. Okay, I think this is clear, guys, very, very clear. What you just need here is to calculate theta. So what can I do? I can divide by 300 here by 300. So this is going to cancel. So I'm going to remain with cos. Okay, I'm already written in blue, in this in red, guys. Let me just change. Cos theta will be equal to this value here because we've divided by 300 to cancel this. So you're going to be left with 60 cos 45 degrees over 300. All right, so this is the question, guys. We want to calculate theta, and we know that from our mathematics, if you are given that cos theta is equal to maybe a decimal of 0.5 like this, for you to find theta, you're going to use your calculator like this, a cos theta like this, which is just shift cos. So from your calculator, just use shift cos, it will represent it like this. So whether you've got a decimal or you've got a fraction, that is the same thing. So here, in order for us to remain with theta, we are going to have it as arc cos of whatever that you have here, which is 60 cos 45 degrees over 300, like this. This is going to be our theta in degrees. So guys, from your calculator, you're going to obtain something like 81.87. I rounded off earlier. Let me just put it as 695. It's 98 there, not 589. This is what I obtained there. Then I just put this to 1 decimal place, depending with the degree of accuracy in your question paper that you are using. But in this case, I'm just going to use 1 decimal place, which is called 81.9 degrees. Okay, depending, like I said, mostly is 3 decimal places and so forth. Mostly that's 3 decimal places that what they use. Okay, anyways, let's continue this part. What are we going to have here? This is the theta that we needed, and we said from this presentation, the direction, it's north, it's east. If you're using theta, it's east theta degrees to the north. So therefore we shall have our direction as, so therefore you must aim, because the question was asking what you must aim. So therefore you must aim, or we can just say the aircraft. That's all. Let's just say the aircraft, guys. Therefore the aircraft must aim. What must it aim? It must aim east theta degrees to the north. So east theta, which is the angle that we obtained here, our theta here, theta degrees to the north. So which is 81.9 degrees to the north. All right, so this is what the aircraft must aim, or that pilot that we are having, you must actually aim east 81.9 degrees to the north. So that's how, guys, they ask these questions and how you're supposed to answer them. Let's just quickly rush through on the second question. This one is pretty direct. The resultant velocity of the aircraft. Okay, what is going to be the resultant velocity of the aircraft? Okay, this is the concept, guys. When we had our diagram, we obtained something like this. Let me just put this diagram back. Okay, this is what we had. Maybe if I can just, because we have the angle now, so in order for us to have the resultant, we can actually work with because this is the velocity. Okay, so for you just use the vertical components. Okay, let me just use, this is item B, use vertical components. Okay, that is what you're going to use. This is the stage that you're going to do. Use the vertical components in order for you to obtain what? The resultant. So how are you going to apply this? Because we have calculated this angle, and so which means we shall have something like this, guys. Let me just put it fast away because we did this before. So we now have this angle. Remember we said it's 81,9. So you're just going to put your 81,9 here and your 300. All right, and here it was there. It was 60 and 45 like this. Okay, so this will be your new diagram because you calculated the angle theta, this one here, this one, you calculated it. So using the vertical components, you see that this is in the positive. So this is Vy, which is positive, and this one is in the negative. So it's Vy, which is a negative, this one. So the resultant velocity is the difference between these two. That is how you calculate the resultant velocity, okay? The resultant, that is the difference between these two. Or to add, since this one is going to be negative, so that is where you're going to subtract it, but actually you're just going to add them. But because this one is a negative, it is going to subtract, okay? So this is going to be our V is going to be V aircraft, because this one is the velocity of the aircraft, this one, which is on the positive. So it's a V aircraft, all right, minus V boat. Not VA, sorry. I'm thinking of the previous question that I did where I was working with the boat. This time we've got the aircraft, so this one is going to be VA. All right, so this is what you're going to have, guys. That is in the vertical. This one is going to be 300 sine. Remember, vertical components, they use sine theta. These ones, they use sine theta. Horizontal cos theta. Okay, so it's 300 sine the angle. So it's going to be 300 sine 81,9 degrees, which is the angle between this one, okay, minus the one in the vertical here. Already the minus is there. This one, this is the one that we have indicated here. So it's 60 sine 45 degrees. So it's going to be 60 sine 45 degrees. That's how you calculate the resultant velocity. You subtract the velocity that we had, the resultant that we had for the aircraft minus for the air. This is what you're going to put together now. So using your calculator, guys, you're going to obtain something like 254, is it 4? That's 4806, something like that. Okay, so you can round off depending with the degree of accuracy. Let's just put this to 3 decimal places or even 1 decimal place, guys, or 8. This one 48. This is 5.8, not 4. Okay, this is 5.8. I don't know how I wrote these numbers, but that's what I obtained there, which is kilometers per hour. All right, so you can even choose to put to 3 decimal places. To 3 decimal places is going to be like 2,255,581. Yeah, just cross check, guys, on your calculator there, but this is what you're going to have. So this is the resultant velocity. And since we need the direction also, and whenever the vertical component is a positive, I talked about this. This is positive, negative. So positive means you're going to the north, negative to the south. So definitely this is going to the north. So that is what you're going to have for this one. All right, then the other question was the time taken by the aircraft. All right, so that is C. The time taken by the aircraft. What will be the time? Okay, we have the resultant velocity, guys, and also we have got the distance to the airport, because we are given the distance. Remember the distance, it was 150 kilometers. Okay, that was the distance there. The aircraft should fly there. So that is going to be item C, which is time is actually the displacement. That's the displacement of the resultant velocity. That's the resultant velocity. So these are the stages that you're supposed to take, guys. Okay, so this displacement is simply S over V. All right, yeah, let's just put it this way. So the velocity that, the displacement that we're given there was 150. Okay, I don't know where I thrown this paper, but it was 150 kilometers over the velocity, which is the one that we just obtained now, which is 254, this one. this is what you're going to write. So you've got 254,8,58. This is 58 like this. Okay, so from your calculator you're going to obtain 0.58920, something like that. Okay, so you can round off to 3 decimal places depending with what you want. So it's going to be 589. Okay, so this is time in hours, but take note guys of the time that we are obtaining. This time is hours. Guys, this is weird guys, that what we are having here. We are having our time as a decimal, 0, whatever that you're having there as a decimal. So what are you going to do? We can actually convert this to minutes and seconds there, because as you can see we've got 0 hours there. So in terms of hours we've got 0 hours, so that means there's nothing that you can write. So how many minutes are we going to have? We are going to take this decimal, the remaining decimal, you multiply it 0.589, you multiply it by 60 like this. So if you multiply this by 60, you're going to obtain 35,34. So this will be in minutes. So as you can see, we have 35 full minutes here, a whole number. This one, that's the number of minutes. So you've got 35 minutes which are going to remain. But as you can see, there's a decimal which is remaining after the comma. You've got 0.34. So you're going to multiply 0.3, because you have taken this 35, so you're going to remain with a 0 there. So it will be 0.34 minutes times 60, so that it can be in seconds. So in seconds it will be 20 there. If you are going to obtain something like 20, so this is now in seconds. So we are going to have a 20 here, which is in seconds. So as you can see guys, 0 hours, whatever that you're going to have. So our time is simply 35 minutes 20 seconds. All right, so this is the time that is going to be taken. Oh guys, 35 minutes, I adjusted too much there. That is 35 minutes 20 seconds like that. Okay, so that's how guys they can actually ask these questions. As you can see, these are the typical questions that you need to revise along the side, so that you can be able to answer many questions as you shall be approaching the exams there. But that's what we have guys for Meson African Motives. Till we meet again.